Assalamualaikum and good afternoon to all attendees. Thank you so much for coming. I am Aqilah, and over there is my colleague Hazwan and Halif. Okay. And today, and for this afternoon, we will be presenting and discussing about AI deceptions when AI are taught to lie, also known as adversarial attack. A bit intro about ourselves. We are from Research and Development Unit from ITPSS. Currently, R&D has two teams, AI team and blockchain team, led by Haji Fahmi, who just gave a talk this morning about deepfake. As of now, we have taken AI courses from multiple sources, such as Oxford University and few from deep learning. Recently, we have finished our SANS training focusing on securing web API and microservices. Before going further into discussing on artificial intelligence, first we'll talk about the fourth industrial revolution and why it is important to artificial intelligence. We are entering the fourth industrial revolution, the combination of artificial intelligence and automated machines. This technological advancement has ability to transform the world. It will affect human labor, ethics, government, and quality of life. To understand why, first consider the three industrial revolutions to come before it. The first industrial revolution was mechanization, utilizing water and steam power to increase production. The second industrial revolution began with the assembly line, harnessing the ability of electricity to mass produce all sorts of products. Whereas the third industrial revolution exploited recent development in electronics and information technology, which is automating production. Today, the fourth industrial revolution is characterized by consolidating current automated machines with improved technologies and intelligent computer systems. It also can be described as the advent of cyber-physical system, involving entirely new capabilities for people and machines. Its technologies such as artificial intelligence, augmented reality, robotics, and 3D printing are rapidly changing the way humans create, exchange, and distribute value. Next, we will be discussing about one of the factors contributing to fourth industrial revolution, which is artificial intelligence. So, what is artificial intelligence? Artificial intelligence is a technology that allows machines and computer applications to mimic human intelligence, learning from experience via iterative processing and algorithmic training. Artificial intelligence, or AI, is a broad branch of computer science that is focused on the machine's capability to produce rational behavior from external inputs. The goal of AI is to create systems that can perform tasks that would otherwise require human intelligence. You can think of AI as being a form of intelligence that is used to solve problems, come up with solutions, answer questions, make predictions, or offer strategic suggestions. There are four types of AI technology, which is machine learning, deep learning, computer vision, and natural language processing. Machine learning is a subfield of AI that uses algorithms to automatically learn how to perform a given task without being explicitly programmed with rules. Whereas deep learning is a part of machine learning that uses a set of algorithms called artificial neural networks inspired by the human brain. It is the closest algorithm that tries to mimic the human brain. Now, most of AI ML problems are primarily solved with deep learning. Natural language processing is a subfield of AI that uses algorithms to understand, interpret, and manipulate human language of text and speech. The final one is computer vision. Computer vision is a subfield of AI that uses algorithms to understand images and videos the same way a human eye does. Today, the amount of data that is generated by both humans and machines far outpaces humans' ability to absorb, interpret, and make complex decisions based on that data. AI forms the basis for all computer learning, and it is the future of all complex decision-making. I will be explaining 5 purposes of artificial intelligence. The first one is AI can reduce human error. When programmed correctly, AI can significantly reduce mistakes. AI wouldn't replace human intuition and knowledge, but unlike human, AI can't get exhausted or stressed. Number 2, AI can work dangerous jobs. AI, specifically robotics, are being deployed across numerous industries to automate dangerous jobs. Robots are resilient machines capable of performing tasks that are unsafe or unpleasant for humans. Automating hazardous work with robots prevent workers' injuries and negative health effects. Number 3, AI helps in repetitive jobs. AI automates repetitive learning and discovery through data. AI performs frequent, high-volume, computerized tasks, and it does so reliably and without fatigue. Of course, humans are still essential to set up the system and ask the right questions. Number 4, AI is available at all times. Unlike humans, AI can perform tasks all day, every day, 24/7. This is especially useful for customer service and other helplines, which is a huge industry for AI solutions. As the technology gets more advanced, always available AI chatbots will only become more effective. And number 5, AI works faster than humans. In some circumstances, AI can determine superior outcomes than human-based decisions. This is based on its ability to identify complex patterns in large amount of data due to its superior memory capacity and processing power. When you hear about AI, it might be easy to assume it has nothing to do with you. You might imagine that AI is only utilized by big companies. In reality, AI is encountered by most people from morning until night. I've shown you some examples of AI in everyday life from the slides, but just a quick and relatable example. One of the first things many people do each morning is to reach for their smartphones. I believe that most people own smartphones nowadays. And when your device gets unlocked using biometrics such as Face ID, it's using AI to enable that functionality. It uses machine learning algorithms to compare the scan of your face with what it has stored about your face to determine if the person trying to unlock the phone is you or not. Artificial intelligence, or AI, has been widely adopted in various applications, such as face detection, speech recognition, and machine learning. Due to the lack of theoretical explanation, recent work shows that AI is vulnerable to adversarial attacks. Especially deep neural network could be easily fooled by adversarial examples that are in the form of subtle perturbation to the input. The intrinsic vulnerability of AI might incur severe security problems in areas such as automated driving, face payment, and voice command control. Now, I will pass over the mic to Hazwan to further discuss about adversarial attack.
Thank you, Aqilah. Assalamualaikum warahmatullahi wabarakatuh. My name is Haji Mohammad Hazwan bin Haji Baha, and I will continue where my colleague has left off. To name a few, factors such as the availability of big data, more storage available, powerful GPUs with thousands of cores that speed up the machine learning training process have contributed to the revolution or rapid increased use of AI. From what my colleague has presented earlier, AIs are being used to make automated decisions. It can also be said that AI are part of our daily lives. With this, we expect and rely AI to produce and generate accurate outcomes. While AI have many potential benefits, they may be vulnerable to manipulation. As the role of AI continue to grow in many of the applications we use, there are growing concerns of the manipulation of AI, especially among data scientists. To recap, our topic for today is AI deception when AI are taught to lie. What are adversarial attacks? Adversarial attacks are malicious attempts to make AI do something other than what it was originally intended to do, such as trying to fool it into outputting incorrect classifications. The attacks are manipulative actions that aim to undermine machine learning performance in terms of the speed, causing model misbehavior or acquire protected information. It can also be modifying an original image in such a way that the changes are almost undetectable to the human eye. Okay. We move on to the importance of the CIA triad in AI. In the cybersecurity field, we call this as the triangle. Confidentiality involves the efforts of the owner to make sure that data, in terms of training model, data set, is kept secret or private to those who have access and privilege to the data. The next is integrity. It involves making sure that data is trustworthy and free from tampering. The integrity of data is maintained only if the data is authentic, accurate, and reliable. And lastly, availability means that AI is available at any time, required 24/7. The adversarial attacks on AI can be categorized into two, that is white box and black box. From this slide, we can see that the white box is open and it symbolizes that we can see everything inside it. As opposed to the black box, we do not know anything about it. It is closed. In adversarial machine learning, a white box attack is one where the attacker knows everything about the deployed model. For example, the input, model architecture, and specific model internal like weights or coefficient values. It is commonly used in academia to demonstrate attacking crafting methodologies. Okay, for the black box, we assume that the attacker has no direct access to the target model, have no knowledge of its internal architecture or the data structure, opposite to the white box. Next, we provide adversarial attacks examples. The most widely studied area of adversarial attacks involves algorithms that process visual data. As you can see on the slide, it is an image classified as a panda with 57.7 confidence. As you can see on the slide, small adversarial noise is added to the original image. And finally, the original image is classified as a given with 99.3% confidence. In 2014, a group of researchers at Google and NYU found out that it was far too easy to fool their AI with an image of a panda, which neural network correctly classified as a panda from the start with 57.7 confidence. Add a little bit of carefully constructed noise and the same neural network. Now, this image of a gibbon with 99.3 confidence. This is clearly an optical illusion, but for the neural network. When comparing the two images here in the slide, we humans can clearly see that both the images look like panda. But in fact, we can't even tell that some noise has been added to the original image to construct the adversarial example on the far left. In this example, the AI researchers added a layer of noise to the image. This noise is barely perceptible to the human eye. But when the new pixel numbers go through the neural network, they produce the result it would expect as the image of a gibbon. So if you guys are wondering what is a gibbon, Google search shows that this is a gibbon. It is a small kind of apps. Okay, moving on. Here we see that how AI is manipulated when when it sees a stop sign. A group of researchers showed that it's possible to trick visual classification algorithm by making slight alterations in the physical world. A little bit of spray paint or some stickers on a stop sign were able to fool a AI classifier into thinking it was looking at the speed limit with 100% of the time instead of a stop sign. Third and last example, in 2016, researchers at Carnegie Mellon University developed glasses that often had a success rate in confusing facial recognition technology into identifying them as someone else. As you can see in the slide, for figure B, a white male researcher wearing the glasses was able to pass as American actress Mila Jovovich, trick the facial recognition software with a success rate of 90%. The glasses work by exploiting the neural networks used in face recognition system. The system often focus on things like the color of different pixels and slowly compare to who's in the shot by comparing it to other similar images. If just a small area of the face has been changed, it can completely mess with the attempted recognition, which is why the computer system can confuse two people who in fact look very different. It is important to note from all the examples mentioned that little alterations to an image that are invisible to humans can result in different interpretation from AI side. That's all from me. Halif will be continuing for the final part of the presentation.
Hello. For this slide, I will be talking about on adversarial attack on real life examples. So first, I will be focused on MNIST datasets. So first, what is MNIST datasets? MNIST datasets is a modified National Institute of Standards and Technology datasets. It contains 60,000 small square of grayscale image with a size of 28 times 28. It focuses on a handwritten single digit between 0 and 9. So the task is to classify the given image, which is a handwritten digits, into 1 to 10 classes, specifically representing integer values from 0 to 9 inclusively. So these are our research on MNIST datasets, where we uses 9 random values. For the first one, 100%, all 9 values has correctly predicted the values. For example, in figure 1, it correctly identified the value 0, next one is 4, 1, 9, and etc. So for adversarial attacks, before that, when we generate these models, first, we train the whole datasets, and we uses a single convolutional layer followed by max pooling. And then finally, we flatten the dense layer into 10 units. We train these datasets using 20 epochs. From these figures, as I mentioned before, all of these 9 samples are correctly identified. So these are the adversarial example of this image. So basically, during the neural network training, we are typically engaged in the process called gradient descent. At each step, we will minimize the loss, example the error. The gradient will tell us how much we descend on this lost surface to improve our performance. We treat our input and data, in this case, are fixed. Our output are also fixed, and only our weight are changeable in this case. So we will update our weight to get a little less strong at each step. To generate an adversarial example, as shown as this figure, we will just flip the logic around. So we are now looking for input samples that are similar to real data but end up in misclassified by our model. So our weight are now fixed. In this case, we will continue or treat our input and level as fixed. Now, though, of minimizing loss, we are going to maximize the loss, which is the essence of the loss surface. Our pixel value will affect the loss, and we will ascend on the loss surface. From this figure, we can see we use our epsilon of 0.1 with added perturbation, and the total will be added to the image pixels. In result, from figure 1, 0 will be still recognized as a 0, but on the next figure, the actual value is 4, and then it will predicted the output as 1. Same goes to 1, it will predict as a 7, and as you can see below, the actual value is 1, but using those adversarial attack, it will tell us the value is 8. So from this, we can differentiate this image a little bit noisy from the original image. So that's where the adversarial attack will take place. If we increase the epsilon to 0.2, the image is much more noisier. And then from this one, the actual value of 0 will also be attacked and will produce a result of 6. All other values remain the same. And if we increase it next by 0.3, the result remains the same as 0.2, but the image are much more distorted in this case. These are one of the examples, as my colleague Hazwan has mentioned, regarding the panda examples. For this case, the expected result is a panda, which is at 99% confidence. And then if we increase the epsilon to 0.4, it will recognize this panda as some animals that I cannot pronounce. And then if we increase the epsilon much more, in this case, if we increase it to 0. I think we increase it to 1. If I increase it to 4.17, it will predict the image as a toy poodle. So it is much far from the panda itself. But the original image doesn't seem to be changed at all. And if I increase it to 7.6, it will recognize it a chihuahua at 99% as well. So this one, if we continue to increase the epsilon, and it will produce a different categorical image in this case. And for this one, if I move it to 69, it will show panda as a shower curtain. So next, what are the implications of these attacks? So as my colleague mentioned as a stop sign, it can cause a self-driving car it will cause a catastrophic disaster of a self-driving car because it can alter the traffic signs. Next, it can also be used by a criminal to disguise a restricted item, weapon, to avoid video detections. It can also be used as a bypass to an access control, such as audio and fingerprint identifications. And lastly, it can be used as stealing someone's identity by wearing special glasses, as my colleague mentioned before. So how to prevent these adversarial attacks? So adversarial attack can be prevented by using adversarial training, which is the developer has to patch this vulnerability by training these machine learning models on adversarial examples, as I explained before. Next, it can also be mitigated by changing and tweaking the model structure. This can be done by adding random layer and extrapolating between several machine learning models. And we can also create a multiple model which are intertwined with each other. So if one of the model is vulnerable to the attack, it will not affect the other models as well. So the most I would say questions are being asked: is attacking machine learning easier than defending it? Okay. So this one you can guys read it on your own. So that's all from us today.